Hello kids, and welcome to your video on direct joint and inverse variation. Playing some classical music here. I'm going to try and put it on a repeat on a loop, but I don't think this video is going to take us quite as long as the previous one. Note that this is in both your online and your purple book. Here's where. Alright, let's get started. So first with some definitions. So direct variation is a function, and it's in the form y equals k times x, where k is the constant of variation, and that k stays constant. It's the same throughout the function. As the value of x increases, so does the value of y. Now keep in mind that this is with regard to absolute values of those numbers, not necessarily true when signed numbers are involved, negatives. An inverse variation is a relationship between two variables that's in the form y equals k over x, or x times y equals k. And again, k is that constant of variation. For an inverse variation, as the value of x increases, the value of y decreases. So they go in opposite directions. Then you have a joint or combined variation, which is where two or more variables vary with y in a combination that might be part direct, part inverse, or a little of each. The equation of a joint variation changes depending on the situation in the problem, but it will still contain a constant of variation, k. So now we have the 1812 overture in the background. I didn't expect that one to come on, but apparently I have that in my iTunes library. All right, well, let's take a look at some examples of these types of variation. All right, let's translate some problems. Y is directly proportional to x is the same thing as saying y varies directly with x. So if y is directly proportional to x, that means y is directly proportional to x. We're multiplying them, k times x. But the next one we have y is inversely proportional to x. Same thing as y varies inversely with x, or as x. Y varies inversely as x. So the k goes on the top and the x on the bottom. Just think a moment about that. As x is getting bigger, y is getting smaller. Because the bigger x is, the smaller this fraction is. And then we have jointly. Y varies jointly as x and z. Y varies jointly as x and z is k times x times z. So when it says jointly and it doesn't say anything about inverse or direct, it just says jointly, it's like they're both direct, x times z times k. And again, you still have that constant of variation k. And then the last one, y varies directly, so I know I have y equals as the square of x. So directly as the square of x means directly as k times x squared, and inversely as the cube root of z. So inversely as our fraction bar, the cube root of z. It looks complicated, but we just followed the directions. Keep in mind in an expression like this one, you could pull that k out front too if you wanted to. You wouldn't need to leave it in the numerator of the fraction. All right. Example time. Direct variation first. So I want you to try these out. I want you to just follow the directions in each one. So finding x, answering the word problem, and then a second word problem. I need to pick some more music, so I'm going to pause the video myself, and then I'll come back and do the problems out. All right. If y varies directly with x, so we are assuming this right here. So everything on this page, direct variation. All right, suppose x equals -2 when y equals 3. Find x when y equals 15. There's a couple different ways to do this. I could use my equation y equals k times x, find k, and then use the formula to find the missing value. Although I don't tend to do that with these, I tend to use a proportion for these. In these problems, you can say x goes over x equals y over y, and you can cross multiply and solve just like you would any proportion. So 3x equals -30, 3x equals -30, and x equals -10. Easy peasy. All right. Suppose X represents the length of a shower in minutes, and Y represents the amount of water in gallons that's used. A 5-minute shower uses about 15 gallons of water. Find the constant of variation and write an equation to model the situation. All right, so Y equals K times X, right? So let's think again about that formula. Write it in terms of K. Like if I wrote K equals, what's the relationship X and Y? Well, it's Y over X. Y over X is equal to K. So if you ever want to find the constant of variation, just put the Y value over the X value they give you. So in this case, 15 over 5. And boom, constant of variation. To write the equation, you just write it as K times X. Y equals 3X. Awesome. A salesperson's commission varies directly with his sales. For $1,000 in sales, the commission was $85. What is the commission for $2,300 in sales? Now, conveniently, this problem says nothing about us finding an equation, so that means we can use a proportion for this one. So $1,000 is the sales to $2,300 in sales, 85 in commission to, well, let's just put C in commission. All right, cross multiply, 1,000 times C equals 85 times 2,300. This always happens in these videos, and I end up having to do the math out myself. So forgive me, children, while I open a browser window to do it for me, because there's just no reason that I should be multiplying that out by hand. Yes, I know, I should have brought a calculator. My cell phone battery's dead, so I am full of excuses, aren't I? All right, 195500. So 195,500 divide by 1,000. So there's 2 zeros knocked off, and then 0.5. So 195.5. $195.50. All right, let's move on to inverse. I apologize for having a bit of an editing jump. I was working on the slide, and then a song came on that I definitely couldn't leave on. No. Anyway. Inverse variation examples. All right, suppose X equals -2 and Y equals 3. Find X when Y equals 15. Well, we'll start with, we know we can use our equation. Y equals K over X. And again, because we can rewrite, we know that X times Y is equal to K. X times Y, the product of X and Y is what stays constant in an inverse variation. I can also use that in an equation format. I can say X1, Y1 equals X2, Y2. Or in this case, rather than 1s and 2s and X's and Y's, I can just go ahead and plug in the numbers. So -2 and 3 are a pair. They go together. So -2 times 3 equals X times 15, or 15X. So I have -6 equals 15X. So I'm going to divide by 15 on each side, simplifying by dividing both of those numbers by 3, giving me -2/5. So -2/5 is equal to X. Oh, X. There we go. So noticing that Y is that as Y got larger, X got a great deal smaller in absolute value. All right, suppose X represents the number of workers doing the job and Y represents the number of hours it takes to complete the job. If 6 workers can do the job in 3 hours, how long will it take for 9 workers to complete the job? Okay, again, I can use my formula, or I can use the fact that I know what remains constant. It's the product of the two things that vary. So X and Y, the product of X and Y is constant. So if it takes 6 workers can do the job in 3 hours, how many hours, we don't know the number of hours, which was Y, for 9 workers to do it, 9 times Y. So 6 times 3 equals 9 times Y, or 18 equals 9Y. Divide both sides by 9, 2 hours. Less time, more workers, less time. And that should make sense. Okay, the volume V of a gas varies inversely as the pressure on it. This time we are going to go ahead and write an equation for this. The volume, switch colors. Volume varies inversely with the pressure. If the volume is 240 under a pressure of 30 kilograms per centimeter squared, what pressure has to be applied to have a volume of 160 centimeters cubed? And again, I can use my products. I could use the constant products if I wanted to. but I'm going to use the equation, I think, this time. So what's V in this situation? So volume of 240 equals K over 30. So I'm going to multiply both sides by 30. 30. All right, so 24 times 3 is 72. So 240 times 30 is 7,200. So that's my K value. So V equals 7,200 over P. And that means I'm plugging in, for the value of P, I'm plugging in 7,200 over 160. All right, so 16 into 720. I'm going to go ahead and cheat with my browser window again. 720 divided by 16, 45. I'm out of space. 45. And what pressure? So it's 45 kilograms per centimeter squared. All right, on to our last set of examples, joint variation. Okay, and now joint variation examples. Write an equation to model each variation, then find z when x equals 4 and y equals 9. I apologize for the music editing jump. You know I'm not as good at this as I would like to be, but just break up the monotony a tad to have the music in the background, I think. So let me jump right in and get started here. So remember how we're going to write these equations. Z varies starts with z equals. Directly with, so I know we have a k, times, directly with x, so x in a numerator, and inversely with y in a denominator. Let's find the k for the given values. So z is 15 when x is 6 and y is 2, so that's a 3. So in other words, 15 equals k times 3, or 15 equals 3k, which means k equals 5. So now I can plug that back into the equation, and I have z equals, and I have k, so 5, times the x they give us over the y, which is up here in the directions. Find z, right here, find z when x equals 4 and y equals 9. When we multiply that, we get 29ths. So it's an interesting little fraction, but that does take care of that problem. All right, next one. Z varies, so z equals directly with the square of x and inversely with y. So x squared on the top over y. So let's plug in the values again. So I have 1/2 equals, finding k, so leaving it k, x, so 3 squared over 9, not 9, sorry, y, which is 6 actually. So 3 squared over, the square of x, inversely with y, which is a 6. Okay, so 1/2 equals k times 9 over 6. And 9 over 6, if I divide them both by 3, is going to be 3 halves. So 1/2 equals k. Oop, not 1. Sorry about that. Oop, 1/2 equals, editing jump, I apologize, k times 3 halves, or 3 halves k. So we can multiply both sides by, I guess, 2/3, leaving us 1/3. So k would equal 1/3. And then we'd have to go back and plug that in. So z would equal 1/3 times x squared over y. So we'd end up with, it looks like 16/27. Yeah, goodness, that comes out. That's complicated. Just double checking my math. Multiply both sides by 2/3. Be 1/3. 2's a cancel. Yeah, ugly fractions, but it'll do. All right, the last one, we're just going to write an equation. They give us enough information to write an equation. The number of buckets of paint N needed to paint a fence varies directly with the total area A of the fence and inversely with the amount of paint in a bucket. So, number of buckets varies directly with area and inversely with amount of paint in a bucket. Let's find K. It takes 3 1-gallon buckets. So number of buckets equals K times area, 3 1-gallon buckets to paint a 72 square foot fence. And they're 1-gallon buckets. So that means that k has a value of 1/24th in order to give me that. So that means n equals 1/24th times a over p. So a over 24p, and that would be the basic formula there for that problem. And that should take care of all these examples. I know we did a lot of examples, and we'll have more in class. And I promise this, it's word problem heavy, but it's not that hard. It's pretty easy. All right, guys. See you in class. Equals